very powerful tools within KASEMAKE. They can be used to make layouts for POP displays or packaging designs. To start a parametric, we go to our parametric toolbar, click Run. Then in the KASEMAKE folder, we'll go to parametric designs. We'll go down to POS, and for the purposes of this demonstration, we're going to go to freestanding display units. We'll click on the first one. As you can see, we came up with a freestanding display unit that's capable of holding a variety of different consumer products. It could be bottled products, it could be something in the order of CDs, DVDs, or food products. From here we can change any of the dimensions of our freestanding display unit to accommodate the particular product we want to display. For instance, if we wanted to display CDs, we might want to change the cell length to 5 inches, the cell width to 5 inches. We'll leave the cell depth at 4, change the number of horizontal cells to 4, and jumping down, what we'll do is we'll change the material to an E-flute cardboard material. So now what we have set up is to create a layout for 4 cells by 4 cells, each cell having a width and height of 5 inches and a depth of 4 inches. When we run this parametric, we can see we have the display that we intended to lay out. Now if there's anything about this particular layout that we didn't like, we can always go back, right click, and go to variables, and we can change any portion of this freestanding display unit as we see fit. For instance, if we wanted to go to a 5-cell horizontal array and 5-cell vertical, that would give us a total of 25 cells, each cell having a height and width of 5 inches. We could also change the material from E-flute to a B-flute, possibly because we decided we needed more strength in the cardboard material. And we go ahead and run this, and what we have here now is a 5 by 5 cell freestanding display unit, each cell being 5 inches by 5 inches. So what we've done here is we've actually changed the dimensions of the layout to compensate for the thicker material so that the inside dimensions will remain the same. This is really the power of the parametrics, being able to change your design for different types of products and automatically changing dimensions to compensate for different material thicknesses. The next thing we want to do is take a layout, overlay some graphics on it, and then create a 3D image from it. This is actually a layout we created. It's been modified a little bit. We added these contours to accommodate the graphic we want to use. So at this point what we're going to do is we're going to bring in the graphics. There's going to be 2 sets of graphics. Now each set is going to have a calibration point that was created by the KASEMAKE operator and then matched with the graphic artist. And choose to actually match the graphic with the layout. So we'll bring in our second image here. Make sure our calibration points are lined up. Okay. Then we're going to go ahead and create a 3D image. We're going to do that by clicking this icon. It's called Fold Box. We're going to say OK. Click the bottom of each of these components, and then we're going to create a 3D view. This is the 3D portion of KASEMAKE. In the 3D environment, the first thing you'll notice is the toolbars are different. We have toolbars for lighting, we have toolbars for different ways of viewing the image, whether it be from wireframe or a fully rendered object. We can rotate the object in different axes, and we select different portions and rotate in different ways the object. We also have a toolbar to create animations. It's easy to create animations in KASEMAKE. To create an animation, start with the components laid out in their original position. Then assemble and fold the components until you have a final product. KASEMAKE will fill in all the movements in between the beginning and the end to create the final animation. Animations are useful for customers and clients to help them visualize how the final product will be assembled. Now that we have a fully assembled 3D object, we can take a look at different aspects of it. We can view the object as a wireframe without hidden lines, a textured object with no graphics, or a fully textured object with graphics. We can also adjust lighting for different situations. We can experiment with different lighting schemes and see how different lights from different areas affect the final 3D object. The other thing we can do is we can actually rotate it. We can look behind it. We have the capability of looking underneath it from below the floor or from above the floor. To add a little more realism to this object, what we can do is we can apply a texture to the floor that it sits on. In order to apply a texture, all we do is import a graphical image, such as a JPEG or bitmap, to tile or stretch over the floor. This is an example of a wood floor image that was created and applied to this particular object. Now, we still have the capability, even with the textured floor, of rotating the object and still viewing it from the top or bottom or any other angle. We can also apply other textures. Here's an example of a tile floor. Tile floor gives a little different perspective, and it actually changes the lighting a little bit. So what we may want to do is experiment with different lighting schemes to see what works best for this particular floor. We can place our object in different environments by using background images. Background images would typically be pictures of insides of stores or other retail establishments. Once we have the object in the scene, we can adjust the lighting to find the ideal lighting scheme for this particular background. We can also rotate the object to different angles, or we can move the object to a different location. Freestanding display units or other packaging material is typically shipped flat. That means that at the customer site, they must unpack it, fold it, and assemble it. It would be useful to have instructions that illustrate these steps. KASEMAKE gives the user the capability of capturing 2D images from the 3D process used to originally assemble the product. These images can then be compiled into one sheet that the customer can use to assemble the product. Annotations such as text or numbers can be added to the instructions to clearly illustrate the process.